Hello, I'm Eirini Politi and I work for Brockmann Consult. I also chair the Lagoons for Life initiative, which was established back in 2017 to look at holistic, sustainable management of coastal lagoons around the world using remote sensing. Today, on behalf of my colleagues, I will be presenting to you the CERTO project, Copernicus Evolution, Research for Harmonized and Transitional Water Observation. CERTO is funded by the European Union's Horizon 2020 Research and Innovation Programme and aims to generate operational remote sensing water quality products to suit the continuum of transitional systems. We kicked off in January 2020 with a plan to be a 3-year project. Before I start, I'll give you a bit of background on how CERTO fits in the environmental and climate monitoring theme from an Earth observation perspective. The Copernicus program is a major European Union initiative for Earth observation. It is coordinated and managed by the European Commission, together with the European Space Agency, the EU member states and EU agencies. Together, they aim to achieve a global, continuous, autonomous, high-quality, wide-range Earth observation capacity. It's of no surprise that Copernicus is a European contributor to the GEO system of systems. Copernicus has 2 key elements: the Sentinel operational satellite series, with multiple satellites having already been launched, and many more to come in the future years. From polar orbiting to geostationary satellites, with sensors ranging from the optical, thermal to microwave, and many parameters being monitored, we have a wealth of data that feed into the second key element of Copernicus, the 6 thematic services that provide data and forecasts to a wide range of users. These are climate change, marine monitoring, atmosphere monitoring, land monitoring, security, and emergency management. 3 of those provide water quality data and information to end users, namely climate change, marine monitoring, and land monitoring. However, these 3 services use different methods and approaches for the ocean, shelf, and inland waters, leaving transitional waters uncovered. So as you can see on this slide, the 3 Copernicus services cover different water bodies using different methods, leaving the transitional waters uncovered. That's where CERTO comes in, aiming to harmonize the information provided across the 3 Copernicus services and cover all water bodies by adding transitional waters to the mix. The main output of CERTO will be a prototype. This will be open access, and it will contain water quality data and water quality indicators. The data include water color, governed by water constituents like phytoplankton, sediments, or color dissolved organic matter. The aim of CERTO is not to produce new algorithms, instead to use state-of-the-art algorithms based on the optical water type classification of water bodies and apply the most suitable one or suite of algorithms per water body. Using the CERTO prototype, and based on user requirements that we're collecting, we're also adapting existing and developing new water quality indicators that can be used across the continuum of water bodies, from planning and management indicators relevant for industry and local authorities, to harmonized indicators that can be applied consistently from lakes to coastal zones, to land indicators to establish pressure response relationships, up to a higher level social ecological system vulnerability index called SESV that is adapted for lagoon and estuary systems we are supporting the implementation of national, international regulations and global aspirations, such as the EU Water Framework Directive, the EU Marine Strategy Framework Directive, and the UN Sustainable Development Goals. We have 6 case studies, 3 lagoons, and 3 estuaries, in which we aim to test our data and products and demonstrate our indicators. And even though we have selected the 6 European studies, the aim is for CERTO to be applied worldwide. Even though this is still a work in progress and our main CERTO outputs are not here yet, I would like to share with you the data portal, which will contain our products and indicators when these are ready by the end of the project. If you click on the link on my slides, it will direct you to the landing page of the data portal. Here you can log in and collaborate with others. I haven't, you don't need to in order to be able to use the portal. You can change the display settings, for example, change the base map layer into a different one, show the country borders, display the graticules for latitude and longitude, or change the projection. If you had already used the portal and created plots, they would be listed here. Under the Indicators tab, we see that we have the 6 case studies listed with a list of parameters underneath them that we use internally in the project to develop our indicators. These are now based on Sentinel-2 data. I'm going to choose one as an example to run with this demonstration. This is a chlorophyll A concentration retrieval algorithm, and we have it here for the Tagus estuary, which is in Portugal. So if I zoom in, you can see the different chlorophyll concentrations, the values of which are shown on the legend. The unit is shown here. The algorithm that I used as an example is here. And the acquisition date and time of this particular satellite image is shown here. At the bottom, you can see the whole archive, the black lines indicating all the dates for which we have available acquisitions. And here you can change into a different time so that you can see data from a different period, a different date. Gaps in the data mean that we either have clouds or very shallow waters and bottom reflectance, or any other reason that, that meant that the data had to be masked out. If we look at the different tabs provided here, we can have the display on or off. We can adjust the minimum and maximum shown on the legend. We can make it into logarithmic or not. You see that the changes are applied automatically. So the color changes accordingly. In the information tab, we have the processing system, the whole range of the archive, and email for any support you may need when using the portal. And we can also create plots. In order to do that, I can draw a polygon or an irregular polygon in my area. And then I can download the net.cdf already, or I can make a new plot. When you click here, a new window pops up where you can edit the title of your plot. You can choose the type of plot. I'm going to choose time series, and the range. Here, the whole length of the archive is by default selected. We can create the plot and let it run. It will run for a minute or so. I can show you already one that I created earlier. You can delete it, copy or edit it by, for example, editing the title there or the time range. or you can open it. Here, you can hover over the red dots, each of which shows the mean for that square that I selected earlier on my map. And you get this information on the acquisition date and time, the mean value, and we're looking at chlorophyll concentrations, the maximum and the minimum within that box, the standard deviation, and the median. If you hover over any of those red dots, you get the same information. You can activate the wheel zoom in and out. And by activating the pan, you can pan around your graph. You can also download it by clicking on the download button here. So back to the presentation. The take-home message is that the CERTO prototype will be open access and open source. Still a work in progress. Please bear with us whilst we finalize it in the next 1.5 to 2 years. CERTO does not aim to develop new algorithms. There are so many good algorithms out there. We use the optical water types approach as a decision-making tool on which existing algorithms to apply each time. This will optimize water quality retrieval per pixel and per image, allowing for seasonality and for spatial variability to be accounted for. One algorithm doesn't suit all. Water quality EU products and indicators will be produced, and these will be harmonized across the continuum of water bodies, which is something we currently do not have. The project duration, to remind you, is 3 years, aiming to finish in the end of 2022 or early 2023. With this, the partners from the CERTO Consortium and I thank you for your attention, and we look forward to be hearing from you, either using the contact form or on our website, the email, or as a follower on Twitter. Thank you.